Wake up. Alrighty, folks. Thank you very much for coming today. Today we're going to be talking about how you can maximize the benefits of a Microsoft private cloud through automation, self-service, and rapid provisioning. My name is Glenn Sizemore. I'm a technical marketing engineer and reference architect at NetApp, and I'm the lead designer of all of our Microsoft private cloud architectures. On the agenda today, we're going to start off with a brief introduction to NetApp for those of you who aren't familiar with us and what we do. And then we're going to go through the various components that make up a Microsoft private cloud, kind of breaking it up and taking it in chunks, starting with the bare metal hypervisor, starting with the base OS, moving up into the hypervisor, and then up into the cloud itself. You're getting handed out little tickets as you come in the door. It's for the Surface Pro that we've got up here on the stage. We're going to be raffling that off at the end. So if I'm boring you to death, you could always just power through it for the sake of a free computer, or lower your odds. Your compadres around you want you to leave. Okay, so real quick, throw your hand up. How many of you are familiar with NetApp? Almost the whole room. Outstanding. Thank you for coming. Okay, so for those of you who are new to us, NetApp, we're a storage company. All right, we make hardware. We're Fortune 500. Last year we closed just over $6 billion in revenue. 77% of the Fortune 500 are NetApp customers. But we're also kind of infamous or famous, depending on which side of the aisle you're on, for just being a great company to work for, a great place to work. Every single year we finish highly in the multinational Great Place to Work, Fortune's Great Place to Work, as well as being honored almost every year with an Innovation Award. So I can tell you from firsthand experience, it's a great place to work, a lot of fun, a lot of challenging technologies, but none of that really matters to you guys because you don't work for NetApp. What matters to you is we're the inventor and caretaker of the world's #1 storage management operating system, Data on Tap. Data on Tap is the heart of the broadest range of unified storage in the industry. It is what enables us to do what we do, whether you are looking at our entry level at the FAS 2000 series all the way up to the big boy in the FAS 6000, or using a V-Series gateway to front-end your existing HPS, HP, EMC, HDS storage. It's the foundation that gives us a unified architecture to speak unified protocol and unified management from a single box. All protocols, iSCSI, Fibre Channel, FCOE, SAN, SMB3, NFS, you name it, we speak it. And then it's also the platform from which we add on our virtual storage tiering technology. But again, this is MMS, so you guys probably aren't that interested in that. The part that you're interested in is that third bullet. It's the common software interfaces and management tools that we provide to plug into your existing infrastructure. So why should you listen to us? Well, Microsoft honored us last year by naming NetApp as the Microsoft 2012 Private Cloud Partner of the winner of the Microsoft Private Cloud Partner of the Year. This is actually a big deal. We're a storage company. Private cloud, that's not about storage. It's not a technology. It's not hardware. It's a business process. It's a collection of ecosystems. We were competing against service integrators that's all they do is come on site and teach customers how to build private clouds, how to change the business and how it works. So how do we do that? How did a storage company get to this position? Well, the answer is we took a look at Microsoft's private cloud architecture, which, in this room, when you hear private cloud, in your head you should say the word System Center, because that's really what we're talking about. We took System Center and Windows Server 2012, and we said, well, this is actually a very clean architecture. It's a solid stack for us. It aligns nicely with our baseline that we rely on. And it covers all the touch points that we consider required in any private cloud architecture. But above all of that, it gives us plugins and hooks to be able to extend what they've already built. So for instance, when we talk about automation, well, Microsoft has chosen Windows PowerShell as their primary driver to do the truck of the data center automation. And through PowerShell, obviously, we can just write a module or a snap-in. Well, we did just that. We wrote the Data on Tap PowerShell toolkit. It's our PowerShell v2 module that fully compatible v3 and up, over 1,200 commandlets, and that's our baseline. But we also have native integration with SCOM and Virtual Machine Manager and Orchestrator to just let you stay in the UI that you want. We don't come into the data center and say, okay, you chose NetApp storage, so now here's these 35 different servers that you need to install to manage it, and we're going to proxy through this, that, and you take your existing infrastructure, we plug into it, and we make it more intelligent. So that's who NetApp is in a nutshell, for those of you who are new to us. So now let's just get going, and we'll try to get through this. There's a ton of information to cover, so we're going to kind of try to move kind of quickly. If you guys got questions, throw them up. If I can take them, we will. If not, I'll ask you to hold them. So Windows Server 2012, massive release, right? A year later, we're still digesting everything that was in that box, all the features that were delivered with that payload. But one of the most important ones from our perspective was the manageability that came in that release. Starting at the top, the commitment to Windows PowerShell and allowing the administrator to automate the entire lifecycle of the server OS in the private cloud infrastructure, as well as an effort to kind of rein in the industry with storage management in storage spaces and storage pools. For NetApp, our integration into these is pretty clear, right? We start off with the Data ONTAP PowerShell toolkit. That's our go-to animal, especially for this crowd. That's what enables us to do blanket management of the entire controller, the entire ecosystem, the entire cloud architecture. It is a Windows PowerShell wrapper around our Data ONTAP Manage ONTAP SDK. That's the API that the array uses for manageability. We drive this toolkit through our communities, right? So the way that a release schedule works, we release every 3 months, so we have a quarterly release cadence. And at the beginning of every 3 months, we go to the NetApp communities for the toolkit, and we look at what our users are asking for. And we prioritize those requests, and that's how we figure out what goes in the next release. This isn't something that we use to drive technology down to you. This is something that we build to enable you to make our storage go better, faster, stronger, right? So if you don't like the way something works, drop a note. We'll get it fixed in the next release. We're pretty agile when it comes to that. We've been shipping for over 3 years now. We're currently at version 2.4, and we have 1,200 handcrafted commandlets. This isn't auto-generation. Each one of these is written from scratch to support pipelining and IntelliSense and all the fun features that have been added to PowerShell. But then we have the other side of the house, right? Part of one of the features of Server that Microsoft is particularly touting is the ability for Windows to manage your storage systems. And it is a pretty powerful feature. I think it's a feature that was derived from the fact that the storage industry as a whole was kind of out of control, right? We weren't really good citizens of the data center. We were asking you to run multiple different tools, and no two vendors looked alike, and running a heterogeneous environment was kind of a nightmare. Now, I happen to believe that NetApp was one of the few good citizens in that space. Right? We've been in SNIA from the very beginning. We take SMIS and our integration in there very seriously. We've integrated natively with tools like PowerShell, and we also have GUI extensions for those who don't want to do the automation themselves. But nevertheless, there were those that weren't behaving. So Microsoft came out with storage spaces and the SMP plugins. For NetApp, that integration point is through SMIS. That's how we've chosen to support that feature in Windows. And as of version 4.1, we fully support Windows Server 2012 as well as System Center 2012 SP1. We have passed the SNIA Conformance Testing Program 1.4, which is required for SCVMM 2012 SP1. And our provider is agent-based, so we support Windows or Linux. We also still have our legacy snap drive for Windows product. Right? This is an all-in-one GUI management utility. Its primary workload these days is it's our hardware VSS provider. This is how we quiesce a physical LUN presented to a storage backended on a NetApp controller, but it also has the ability to provision storage if you choose to use so. So what we're trying to get across here is we're a good data center ecosystem. We're not trying to come in and bully you into a certain way of thinking or using a certain tool. We have our own custom tools. We have our own products. But we also offer the native integration so you can stay in the tools that you know and love, and you don't have to change the way you do operations. So now let's kind of break this in, and we'll kind of go through it. For those of you who haven't seen it before, this is what storage management from SMIS looks like. It's actually extremely clean. So we're going to start here with Windows Server 2012, and we need to provision a new clustered shared volume. So we're going to go in Server Manager and load up our file and storage services roles, go inside storage pools, and then storage pools is then going to access our SMIS provider to reach out and inventory the array or the controller. Here we can see the various aggregates or storage pools that pop up. We're going to create a new LUN for this system, so we're going to go down to virtual disks. Now you can also notice here the deep integration that we're getting. We're returning back the actual disk layout of the aggregate or the storage pool. But we can go in and we're going to create That was interesting. We're going to create a new LUN by creating a new virtual disk. It's all GUI driven. There is a PowerShell interface to this, but honestly, if you're going to use PowerShell, we're going to recommend that you use our toolkit. You're going to see in a minute, it's faster and it's more powerful, but you can do all of this from PowerShell as well. So we're going to give it a simple name. This will be the name of the LUN that it creates on the controller itself. Of course, we want it to be thin provisioned, and we'll just set aside a size. We'll set our masking, and then we'll just tell it to go. And it's going to go out, create the LUN, do the masking, present it to Windows, initialize the disk, and then place it in available storage inside Failover Cluster Manager. So it's a real simple UI, no complex touching the actual infrastructure. You don't ever have to log into the controller itself. You can do it all right from Windows. And then automatically, we're just going to go ahead and format this volume. Just simple NTFS. We don't want to give it a drive letter because it's going to be a CSV, so we're going to use a mount point. And there we go. Done and done. So about a minute and a half to present new storage right there from Server Manager. We'll pop inside Failover Cluster Manager and just flip this to a cluster shared volume. And then we're going to rename it. If you haven't started doing this, this is really important. You want to rename your CSVs. We recommend that you both rename both the actual resource inside Failover Cluster Manager as well as the mount point. But at a minimum, make sure those are the same. It's just going to reduce operational errors by offlining the wrong resource or removing the wrong resource. It just makes it easy. Okay? So that's SMIS. That's the baseline. There's no differentiation here. We could have just provisioned storage on an EMC or a 3PAR or anybody. It doesn't matter. That's the whole point, right, to level it out. Now, the only problem with that is, as a storage vendor, I can tell you we're hard at work trying to come up with ways to enable new technologies and to change your business models and do things differently. And that's obviously going to lag pretty significantly behind the standards-based way of doing things. So how can you get into that? Well, that's where our PowerShell toolkit comes into play. So here we have, this is our UI. This is our system manager, the tool that we provide. And this is connected to a data on tap clustered controller. And you can see here we have a series of virtual servers. Virtual servers are a containerized logical object from which you put both the back end, so the volumes, the LUNs, as well as the front end, the data ports, the initiators. And it gives you secure multi-tenancy boundaries for customers inside a single storage system. So we're going to go in here, and we're not actually going to do anything in Server Manager. This is just to show you what's happening. We're going to refresh it here. You can see we don't have an additional vServer, and then we'll refresh the storage inside storage spaces. There's no Julia Child's magic going on here. We didn't pre-stage it. So now we're going to go over to PowerShell, and we got a very simple script, 18 lines. Right? You don't have to read this. It's not important. If you want to know what it's doing, come down to the booth, and we'll go through it with you. But the point here is there's no looping. There's no real complex parsing. This is really just entering commands, right? So we're going to hit go on this script, and we're going to create a new data vServer, so a new logical container. This is onboarding a new client into the private cloud. We're going to create the new fiber channel interfaces to expose the storage to, create new volumes, provisioning the storage itself, the container, and then create the LUN. Now, at this point, we're actually done, right? The LUN's created. Now it's been presented to Windows, and we're waiting for it to come into the cluster. Let's take a couple of seconds. There you go. So that's complete storage provisioning, not just the LUN or the SMB share, but the actual container and all the permissions that go with that and the rules and policies that go with that in about 30 seconds. Right? So it's deeper integration than it's possible without it, and you can see there's our new vServer running all available storage protocols, and we've already provisioned it out. So that's taking provisioning to the next level, and it's enabling you to absolutely maximize the benefit and get the most out of our arrays. Right? You pay for an intelligent storage controller. This is how you can integrate that into your native tools. So moving on into what else did they do with Windows Server 2012 besides make it manageable? Well, they also added some new protocols. Have you guys heard about ODX yet? Show of hands? Oh, okay, about half. So ODX is a new protocol that's been added inside Windows Server 2012. It stands for Offloaded Data Transfer. Simply put, anytime you trigger a copy or a paste anywhere inside a Windows world, it attempts to do an ODX transfer. Now, what's beautiful about this is any tool that leverages a standard copy inside Windows will automatically attempt to use ODX. So all your existing tools, PowerShell, Xcopy, RoboCopy, they'll all attempt it. And then in the event that the array supports it, it'll just automatically happen. Now, the protocol itself is token-based, meaning we move tokens, we don't move data. And by nature, being token-based, it's natively cross-protocol. Meaning the token doesn't care if it's originating from an SMB share or a fiber channel target or an iSCSI LUN. It just cares that the token is there and that it can monitor the token. Now, at NetApp, since we have a unified storage system, we took this technology and said, well, to us, it doesn't matter if it's fiber channel or FC or FCOE or NFS, or it just doesn't matter. A block is really just pointers to us. So on a NetApp controller, we can pick up a token from a block device and drop it on an SMB device, and we'll still be able to offload that. Now, we also have this unified scale-out architecture that spans multiple HA pairs into a single logical management construct. So we can also take advantage of some of the built-in offloads that we have inside that scale-out architecture. Simply put, as long as you're copying and pasting within a data ONTAP cluster, we will always offload the transfer, and we will automatically select the maximum offload possible. So now let's take a look at what this means operationally. I could show you speeds and feeds, and that'd be a lot of fun, but it doesn't really show you why you care. Here we're just going to use the built-in tools inside Windows, and we're going to do something that's going to become pretty regular activity now that we have this technology. We're going to take a VM that's currently on an SMB3 share, and we're going to move it to another SMB3 share for operational reasons. Now, initially, we're going to move it to a share where we've artificially disabled ODX. So we're going to force this copy to go through the host network. So this is going to be our baseline for a traditional array, or if you were using DAS storage, this is what you could expect to see. And now that we've started that transfer, we're going to take another virtual machine that's in the same source data store, and we're going to move it to a new SMB3 share, this time leveraging the ODX transfer technology. Right away, you can see that the ODX transfer has already caught the host-based copy and is succeeding it. So just apples to apples, no speeds and feeds, no technology, just this is without, this is with, and you can see the immediate benefit. Now, it happens to be faster, but that's not the real point. The point is we're offloading the transfer from the host. So we're lowering the processor load, the network load. We're taking the load off the host so you can pack more virtual machines onto it. And now we're going to show off that ability again to break protocol boundaries. We're going to take that VM that we already moved once, and we're going to move it again, this time from that SMB share to a CSV. So this is breaking the boundary from SMB to fiber channel. And again, we get the same speed, the same offload. I'll actually drill in here and show the virtual disk so you can see when they actually flip. There we go. So roughly, how much faster is it? Well, twice as fast, right? We just moved that virtual machine twice using ODX in the same amount of time that we moved it traditionally once. Now, we also know it's actually more than twice as fast because there was a lot of time in there where we were fumbling around with GUIs and cutting and pasting paths. But again, the point of this is offloading the work from the hypervisor, and then in some cases, storage vendors are enabled, and NetApp has done this, to take advantage of that standard protocol and use it to inject some intelligence. In this case, we're using our FlexClone technology to actually completely offload the writes. We're not moving any data, we're just swinging pointers. That's how we achieve the speed that we get. So that's ODX. ODX should be a requirement in any RFP that you submit in the near-term future. This is the future. So now let's move up the stack a little bit and talk about the hypervisor itself, Windows Server 2012 Hyper-V. Now this, of course, was the majority of the payload in Server 2012. This was the big feature, and it's the biggest deal in the industry that's come along, well, honestly, since VMware invented ESX, right? It's that big of a deal. There's a lot of great integration for storage vendors, but all in all, it just works. It's kind of the beauty of it, right? They did a really good job with it, and it just works. So instead of focusing on all the stuff you've already learned this week and last year and ongoing, we're going to talk about some stuff that we've done to help you get the most out of your infrastructure, how to maximize that CapEx investment. We've done some work around virtual disk management. Virtual disks were kind of painful back in 2008 R2. We had a lot of problems with alignment and performance and various operational reasons to choose different types of disk types. In 2012, for the most part, they fixed that. Right? We can finally use dynamic disks for production workloads. They're properly aligned, they scale, and they're safe. But there's still operational reasons why you may not want to do that. The question you have to ask yourself is, where do you want to manage the oversubscription? Do you want to manage it in the host volume of the Hyper-V host, or do you want to manage it in the container or the storage pool at the storage controller? Well, if you manage it at the storage controller, we can do intelligent things like move the data around, expand it, shrink it, do all sorts of fun stuff. When you put the oversubscription point in the Hyper-V host, now you have to manage both the storage and the host itself. But then we get to the operational expense of, yeah, but fixed disks just take forever. Okay, fair point. What can we do to make that better? Up at the top here, this is just going to run our systat. It's a standard performance output. I'll let you know when you need to look up there. It's just to give you a point of comparison to show you how busy the controller is processing any given request. We're going to pop back into our Data on Tap PowerShell toolkit. And first and foremost, we got the CSV here. We got to figure out which volume it actually resides on. Right? So right here, we're going to run this command. And we can see that our CSV is actually sitting on worker A in this MMS demo volume. So if we take a look at that LUN, we can see that we're using about 521 megs of active storage. So now we're going to use the built-in Windows tool, new VHD, to create a fixed-size virtual disk. In Server 2008, this was a slow process. R2, it got a little bit faster, but it still took forever. In 2012, it cooks. But that's both a good thing and a bad thing. It cooks because the 2012 I/O stack is vastly more efficient, and that thing can write zeros really fast. So there we just wrote 10 gigs of data in about 59 seconds. The problem there is you've got the potential, and we can see that we're using 10 gigs of space. So now let's go ahead and create 100 gig fixed-size VHDX using the NetApp tools. 2 seconds. Right? So there's no operational reason to not choose fixed-size VHDs. You can create them in the same amount of time it takes to create a standard VHD or VHDX fixed size. And in the end, I'll tell you how we do it. But we also have all these existing virtual disks. What are we going to do with those? Well, we have the ability to offload those transfers for you and accelerate it. Here we're going to flip this existing VHD into the new VHDX format, giving the expandability up to 64 terabytes and the power protection. And here you can see it took about 20 seconds to flip 20 gigs. And then finally, obviously we just talked about ODX and its ability to leverage our FlexClone technology. For those of you who haven't made it to 2012 yet, we've built a tool here in our copy any host file commandlet to enable you to call those same technologies manually. And we've sped this up, but you can see the controller's bored, right? It's not really doing anything. It's just idle. Meanwhile, we're copying 300 gigs of data. And there we go. 5 minutes and 45 seconds to copy 300 gigs. Now here's the best part. Let's look at the actual LUN. We haven't used any space. Right? This is next generation thin provisioning. This is how we can enable you to get the most out of your infrastructure. In NetApp, the game we like to play is only unique data. Every block that you write, it should only actually hit the disk if we don't have another copy of it anywhere. Right? This is how you really maximize your investment. How many of you are currently Hyper-V customers? Or, sorry, let me rephrase that. How many of you are currently VMware customers? Everybody. Come on, don't lie. You all have it. Everybody has it. You don't have it by choice. You have it because, well, they invented all this stuff, and now we're further along, and now we're ready to start making transitions. The problem is, we've got all these giant files, and how are we going to move operational systems from one hypervisor technology to another hypervisor technology, and how are we going to manage those outage windows? Microsoft's been hard at work. They've got some fantastic tools that will help us automate that provisioning process and the migration process. There are also partners that have been hard at work in the ecosystem and have a lot of great utilities. The problem is the copy. The problem is moving from the VMDK to the VHD or the VHDX. That's where the biggest chunk of outage and downtime is. Now, at NetApp, we happen to have a way that we can make this pain go away. We've developed a virtual disk conversion utility that leverages our FlexClone technology to create space-efficient transition from one virtual disk type to another. So the easiest way to go through this is just to show it to you in action. Here we have our old friend, vSphere. This is latest and greatest 5.1. We've got 29 virtual machines that are up and running in this environment, and they each have 40 gigs of virtual disk space. We have a Hyper-V host, completely empty, ready to be loaded up with this workload. We're going to run a lightweight PowerShell script. If you guys are interested in how this works, come on down to the booth and we'll walk you through the script and show you how it goes. But generally speaking, the point here is just to show you what we can do to help make this transition less painful. So we've loaded up the Power CLI and the Data on Tap PowerShell toolkit, and now we're just going to use Out Grid View to put a lightweight UI on this script. And here we go. Now, for the sake of comparison, we're going to transition everything, so we're just going to select them all and hit OK. We create the VM inside Hyper-V, and now we're going to convert the VMDK to a VHDX. This is making the transition from an NFS data store to an SMB3 share. And now we're going to mount that VHDX to the new VM and start it. So we just flipped from ESX to Hyper-V, and you can see the time, 17 seconds, 18 seconds, 18 seconds, 17 seconds, 19 seconds. You guys think you can get a 20-second outage window? Think that's possible? I could. Now, full disclosure, right? What is this showing? This is showing our ability to rapidly transition from one virtual container, a VMDK, to another virtual container, a VHDX. There's still work that needs to be done. We still need to remove the VMware tools. We still need to migrate the network settings if they're in there. There may be some additional work that needs to happen. So you really need to marry this technology with the existing transition tools that are being developed by the community. But our point is we can lower these transition windows for you and help you bring those outages down to make the transition more realistic, right? Because if you go to the business and say, well, it's going to take 6 months and we're going to be down for 8 hours at a time, that's really painful. But if you can do it on a Saturday, when I used to do it for a living, I could make that happen, right? So here we go. We can see the Server 2008 R2, obviously, modern OS. It just came up. The HAL plug and play, new drivers, do Hyper-V integration services to detect that it's on Hyper-V, and it comes right up. So now we've leveraged PowerShell to create space-efficient virtual disks, and we've rapidly transitioned from the old technology to the new technology in Hyper-V v3. How are we going to back it up? Right? Backup and restore isn't necessarily a required component of private cloud, but it's one that enterprises make required, right? That's what customers actually want to see. So we've been hard at work with our SnapManager products, and our SnapManager for Hyper-V version 2.0, which is coming out later this year. Is our answer to this space. It is a hardware-based snapshot provider, which is absolutely required if you're talking about massive backup data sets in large clusters with thousands of virtual machines. You do not want to use a software-based provider. It's not going to work. It's not going to scale. We've also included the ability to do crash-consistent and application-consistent backups. A crash-consistent backup is where we don't go through the VSS stack to quiesce the guest. We just take a snapshot on the hardware, on the array itself. This is for applications in virtual machines where you're backing up the app data separately. So if you've got an Exchange database or data Exchange, you got a DAG, and you're backing it up with an existing backup application, the backup application is protecting your Exchange data, right? So you don't also need something to go in and quiesce Exchange so you can snap the base OS. You just need the base OS to restore Exchange back onto. And we'll see in a minute the speed that you can get out of crash consistent. It enables RPO opportunities that just aren't possible otherwise. One of the biggest features in Server 2012, though, however, was they did a massive amount of work to the VSS subsystem inside Windows itself. I know NetApp personally just got beat up with Server 2008 R2 and how long it took for us to do backups of some of these environments. And it was just the way the architecture worked. In Server 2012, they fixed it. We're going to see it in a second. It's now fast, efficient, and can scale. And then, of course, we've got Hyper-V over SMB, right? So now, how are we going to back up a VM over a file share? Well, the answer to that is remote VSS. In our upcoming Data on Tap 8.2 release, we're going to introduce support for all of the above, SMB, remote VSS, and the ability to back up and restore those VMs. So let's take a look at what this looks like. This is real basic, right? We're not going to get into the architecture of how distributed CSV backups work. and the guts of our Snap Manager. If you want that information, we've got the pros in the booth. Just come on down. But you can see here we take a backup set of data set. We're going to enable distributed backups, and we're going to do app consistent. So this is the worst case, right? We're going to quiesce the VMs, but it's a small backup set. We're only backing up 3. Just to give you an idea of the user experience. You can see here we triggered the backup. We're retrieving the VM metadata, take the snapshot on the array, save the snap info, that's the VM metadata, and then take a snapshot on the snap info to protect that data, and we're done. So 30 seconds. So I told you it was faster. How much faster was it? We won't get into this game of, well, this product versus our product. I'll just tell you how much faster it is for us. So if I take Snap Manager for Hyper-V 2.0 and I install it on Server 2008, R2, 4 nodes, and I put 500 virtual machines in that environment, and I create a single data set, it took us 146 minutes to back up 500 VMs, right? Not very good. Server 2012, we can back up that same data set, right, in right around 46 minutes. So order of magnitude faster, right? In Server 2008 R2, when we looked at the absolute upper limit of the environment, 1,000 virtual machines running on 8 hosts, that's the max that we supported, we were sitting at 300 minutes to complete that backup. In Server 2012, we can do the same backup in 115 minutes. Now you'll notice the jump from 500 VMs to 1,000 VMs was incremental there, right? It wasn't exponential like we got in Server 2008 R2. That's because of the distributed backup. That's because we farmed the backup out and we can quiesce in unison instead of having to serially crunch through each virtual machine one at a time. Now the story gets even better for crash-consistent backups. In 2008 R2, it was the only way that we could really service large environments with tight RPOs. But even then, you could see 500 virtual machines in 2008 R2 crash-consistent was taking us about 36 minutes. In 2012, we're doing that backup in 9. Right? So you could theoretically back up 500 virtual machines every 10 minutes throughout the day. Just keep backing it up continuously. 1,000 virtual machines in 2008 R2 was taking us 46 minutes, almost an hour, and we weren't quiescing anything. 2012, we're doing that backup in 12. So again, you see the incremental increase. We go from 9 minutes to 12 minutes. So this is the advantage of a hardware-based snapshot provider. This is why we say it's required. It's just not possible to hit those RPO points without something like that. So we've touched on our integration with Server 2012 and how you can get the most out of your infrastructure. We moved up into Hyper-V and showed you how you can take advantage of some of the work that we've done to help maximize that investment. Now let's move up into the cloud itself. Let's talk about System Center and the work that we've done to plug in there. First and foremost, all of this integration comes through our on-command plugin for Microsoft, version 3.2. And we're going to break it up and talk about the 3 primary integration points that we use. They are, of course, they start with System Center Operations Manager. We ship a series of management packs that plug right into Operations Manager, starting with basic data on tap reporting, and then some work that we've done to bring Hyper-V and increase the intelligence of the storage on top of Hyper-V. And then, of course, some pro tips to help automate some basic day-to-day management. What does this mean for you? Well, this means if you're a Windows admin and you don't care about storage, you can go to your storage team and say, hey, can I get a read-only account to this thing? And then inside Operations Manager is going to do all the work for you, right? It's going to give you a logical understanding of what's going on. Why is your application performance suffering? Why is SQL Server not doing what it's supposed to do? Right? Connect those dots for you so you don't have to then go and do a whole bunch of work cross-communicating with the storage team and trying to bridge those gaps. Or you could, alternatively, if you're a one-man shop, gives you another option. You can just leverage your existing single pane of glass to include the storage as well. We also, of course, include reporting. But guys, if you're using SCOM reporting as part of your quarterly review processes or anything like that, you already know how to write these reports. We've just included 17 examples to show you how you can leverage the data that we're putting inside the data warehouse. And of course, I mentioned pro tips. We currently have 17 pro tips, and it's just around the pain points that we see most often pop up throughout our support community. So let's take a look at what this looks like. I apologize for being a little compressed. We're going to zoom in here in a second, but the SCOM management UI really likes to be tall. It doesn't like being scrunched in. So here you can see at the top level, these are just the volumes on the storage controller. We can also look at the LUN objects. or Q tree or aggregates or volumes. The point that we're trying to get across here is that we're actually importing all of the various objects that Data on Tap knows about into SCOM. We're not just doing basic trigger alerting on something like SNMP traps. This is deep integration. SCOM knows what the storage controller likes and doesn't like. So here, taking a logical view of the infrastructure, we can blow out the actual storage itself. From an architecture standpoint, we can see our storage pools or our aggregates. We can see we've got one that's in error here, and we've got a volume that's got a warning state. If we go down to the LUN, though, the LUN's healthy. So what's wrong with the volume? Well, we'll open up Health Explorer, and we'll come in here and see that LUN utilization has tripped our warning threshold of 90%. Right? So this is taking the guesswork out of it. There's an orange triangle. What the heck's going on? Health Explorer, find the pain point, take it to the storage team. You guys need to grow your storage. So now we'll take a look at the physical hardware itself. We've got an enclosure warning. We'll do Health Explorer on the disks. And we see that we've got a disk state monitor that's tripping on data type. Disk hasn't failed yet. It's on its way to failing, though. And this is SCOM giving you a heads up that Data on Tap is preemptively failing the disk because we're detecting immediate storage failure. But we also mentioned that we've got deep integration with the hypervisor. So here we've got Hyper-V hosts inside our environment. Again, we'll do the same thing. We're just going to go to Health Explorer. What's going on with this guy? And we see that we've got a virtual machine that is misaligned. So we've got a Hyper-V host running a misaligned VHD or VHDX. We can also take a look at our Hyper-V LUNs. These are all the LUNs presented to the Hyper-V hosts. And here you can see we've got that LUN with the misaligned VM placed on it, so it's the same corollary. Looking at the virtual disks, we can see that the virtual disk that's causing this warning is running up here at the top, and if we expand out the details, we can see that it's dynamic, and that's what's causing the problem. In this case, it was a dynamic VHD, not VHDX. And then, of course, finally, we've got our virtual machines. So it's just deep integration. What this really does is it provides another connection point for SCOM. It allows Operations Manager to start making jumps that it otherwise couldn't make between physical LUNs and virtual machines and the hosts and the services that are running on them. And of course, for long-term analysis of where's my headroom, am I getting bigger, smaller, we've got performance information. The only one you should really care about is latency. As long as your latency is under 20 milliseconds, the storage system is healthy. If this thing spikes, you have issues. This is where your applications are going to feel the pain if it exists. But it's all in there. We're publishing all this data into the data warehouse, so you can then leverage that for long-term analysis and reporting. Right? So moving on, Virtual Machine Manager obviously is the heart of the actual Hyper-V infrastructure, and we've been asking Microsoft forever for the ability to extend it. And in Service Pack 1, they gave us that with the inclusion of GUI extensions. So now for the first time ever, we can actually drop a vendor-specific UI inside of SCVMM, and we've taken the advantage of that to fulfill a customer request that we've been getting for years now, in the request for the ability to leverage our FlexClone VM provisioning process from right inside SCVMM. So let's take a look at what this looks like. So you can notice right up at the top corner, we've got this little UI sugar for clone VM. So we're going to select a virtual machine, and we're going to hit that. And a very simple UI is going to pop up. We're going to give it a new base name. We're going to clone virtual machine 1. We'll give it NetApp VM. And we'll tell it how many of these we want to actually provision. Give it a destination mount point, and we're going to start them when they're done. Clone. We go over into SCVMM jobs, and we can see we got a job up and running. And we're going to fast forward this because it takes about 5 minutes to, in this case, clone 3 VMs. But there we can see the job finishes 5 minutes later. Go back over to VM and services. We'll refresh our host to force the discovery process a little ahead of time, and we can see those VMs come right up and in. Now, this honestly isn't new technology. This FlexClone capability we've been shipping for 4 years. What's new here is the ability to call it natively right inside VMM without having to go out to third-party scripting or rely on Orchestrator. So it's bringing that technology to a lower price point and a lower lower operational point, not requiring you to deploy the entire cloud infrastructure. You could just do the SCOM SCVMM pair and still get the capability. Okay? So we've been talking about FlexClone. I think it's time to break it down and explain why this is so important. Here at the top, we've got the Windows host view. This is what it looks like inside Windows. We've got a physical disk that we've mounted as a CSV to cluster storage volume 1. On the storage system, however, it's a file inside our data aggregate, inside the volume cluster 1, and it's a CSV1. So when we actually do these copies, what we do is we create a destination file that's the same exact size as the source file, but it's a sparse file. We don't do any allocation, we don't do any writes, we don't do anything. We need a container that's the same size as the source. Then we go inside Windows and we calculate the SCSI LBA ranges of the source file and the destination file. LBA stands for logical block address, and it's the terminology that allows you to map file fragments inside Windows to physical blocks inside the disk called the storage system. So once we have these two block ranges, we pass a single ontappy command to data ontap, saying, data ontap, please link the following blocks to the following blocks. And in the background, data ontap swings the inode pointers, and inside Windows, we get a binary consistent copy of the data without actually copying anything. Now, what's so unique about this is pre-dedupe. We don't have to run a post process to reclaim that space, right? We just never write the data in the first place. This is write avoidance, and it's really where we get the maximum amount of both offload and benefit to you, because you're not eating up space, you're provisioning your data faster, and all around it actually accelerates everything else. The hotter the block we can make inside data ontap, the better the performance is going to be. It sounds counterproductive, but it's just the way our storage systems work. So finally, we're going to end with the grand poobah, right? The workhorse of the Microsoft private cloud, the heart of any modern data center, system center orchestrator. We do offer native integration inside Orchestrator. We have our on-command plugin for Microsoft offers SCO integration packs. Here you can see we have data ONTAP basic management, create aggregates, volumes, LUNs. And then we also support cloning and provisioning, so that clone NTFS file, that's that flex clone technology that we've been talking about. Of course, in Server 2012, we just do a copy-paste and we get the same thing via ODX, but for downrange OSs, we have the ability to leverage that at a band. And then we've got disaster recovery commandlets. Honestly, Server 2012 and Hyper-V Replica is going to fulfill this requirement most of the time, but this is a technology that we developed way back in Server 2008 when DR was really hard with Hyper-V, and it's still in there if you have those legacy environments. But even for those of you who have made the transition, snap mirrors and the ability to manage that is pretty important. Okay, so that's our integration. However, again, as we said at the top, we have all these native tools, and we supply the tools so you don't have to go off and do a bunch of work. But if you really want to get the maximum out of your investment, our toolkit is going to be the bleeding edge, because you come to us and say, hey, I need the ability to do X. We're going to have it in the toolkit within 3 months. Getting it into Orchestrator could take a year, because it's a different product cycle, a different release cycle, right? So now let's take a look at what we call the modern data center. This video was actually recorded a week ago. This is our Fast Track v3 requirement, or sorry, Fast Track version 3 FlexPod environment. This is what we shared with Microsoft when we actually submitted for the validation. At the bottom here, we have our fabric management infrastructure. So this is where System Center is running. Up top, we have an app cluster. This is where general workloads are going to be provisioned into the private cloud. One of the requirements of Fast Track was the ability to provision a new virtual machine host. And SCVMM clearly has that ability to do bare metal provisioning. But we knew we could actually do a little better. So we went above and beyond and said, well, we think private cloud means self-service, period. Not just for the end user, but also for the cloud administrator. The fabric should be managed through self-service because it's faster, it reduces risks, it increases agility. So we went through and actually performed zero-touch integration into Service Manager. So here we need to provision a new host. We're not going to do it from VMM. We're going to go over to Service Manager. We're going to go to a service request offering, and we're going to add a virtual machine host. We're going to fill out a very simple request form. Only requires a name. Everything else we're pulling from the CMDB or deriving. We're going to go to the service request for the purpose of the demo. We've set the request to auto-approve the service request just to speed it up. So we'll just hit refresh a couple times and we should be running, and we are. So now let's flip over to Orchestrator and take a look at that actual workflow. One of my coworkers said it looks like a AK-47 with a grenade launcher on the bottom. I thought it was kind of apt. So you can see here we're pulling the data off the service bus. We're going to clone the service profile inside UCS Manager, and then we're leveraging Orchestrator's ability to thread out. So at the same time, we're going to run the service profile association while we're zoning the fabric inside the nexus. So this is manipulating the actual fiber channel fabric. And at the same time, we're going to clone our base LUN, attach it to a midwife host where we're going to inject the sysprep into the base LUN, and then mount the LUN to the new service profile. At the very end, we start the service profile, and then we're going to wait for sysprep. So let's hit resume and see what this looks like. We're going to hit refresh. Okay. We'll go over into UCS Manager. For those of you who don't know, that's what this is. And we can see our service profile pops in. Of course, we're unassociated. So right now, the LUN's being cloned, the sysprep's being injected, the fabric's being zoned. All this is happening at the same time, but the long pole is going to be the service profile association. So once this is done, we'll go ahead and connect to the console and flip back to our workflow. We'll hit refresh, and we see that everything else is finished, and now we're waiting on the sysprep to run. So we'll flip back to the UI and then skip forward. That, all in all, at this point, it took 10 minutes. So this is 10 minutes from the moment we click submit request to sysprep configuring the virtual switches inside Hyper-V. This is only possible because we didn't have to actually stream the data. We're leveraging that base LUN, the gold master LUN, and we're just leveraging our FlexClone technology to rapidly split off new instances of Hyper-V. And we can see the host name is come in through that sysprep injection. So now going back into Orchestrator, we can see that we're adding the host to VMM because, of course, we want to end with the host in VMM because VMM is going to be how we manage our cloud normally. And we can see that comes in. So this is what gentlemen at Microsoft called a zero to hero demo. We call it zero touch service manager integration, not just for VMs. Anybody can do VMs, but can you provision a physical host with the same speed and agility that's traditionally associated with virtual machines? To us, that's private cloud. Okay. So in closing, we talked about what is NetApp. We talked about our Windows Server 2012 integration, the management integration that we've done with SMIS, the investment into PowerShell, our hardware snapshot provider, the performance advantages of ODX and why it should be a required element in any infrastructure you build going forward, and then our Snap Manager for Hyper-V product that enables you to back up those large environments. We moved up into the private cloud infrastructure, talking about our integration with System Center, the deep integration in Operations Manager, Virtual Machine Manager, and the ability to call those Flex clones and rapidly provision virtual machines right within VMM UI, and then our Orchestrator integration, showing a real-world example of what a private cloud infrastructure actually looks like. So in summary, putting on my sales hat, what if you could deploy a private cloud in days instead of months, cut your storage and power space requirements by 50%, rapidly provision virtual machines via orchestration, and integrate all of this with self-service portals? Well, if that's something you're interested in, we've done some work back in the lab, and this week we've announced our latest FlexPod with Microsoft Private Cloud. It is a Fast Track 3.0 validated design. We've already gone through the work. It's pre-validated today. It's fully integrated with System Center 2012 SP1 and the Cloud Service Process Pack. It's based on FlexPod, and we believe it is the most scalable Hyper-V platform on the market, period. However, we understand that this is a big infrastructure. Right? You got to be of a certain size to look at this. So we've also been doing some work to address the smaller end of the market, not only for small businesses, but also for the edge of the market. What are you going to do in your distributed branch in the edge of your data center? For those smaller environments, this week we're announcing our ExpressPod with Windows Server 2012 reference architecture. This is an entry-level reference architecture. It's a lot smaller, smaller base config. It's iSCSI only, so we don't use Fiber Channel or SMB. We've documented small and medium configurations, 2 and 4 node configs, and all the hardware and reference implementations are shipping today. This isn't as flexible as FlexPod, right? FlexPod is called FlexPod for a reason. We customize this for you. We come in and figure out exactly how much compute and servers you need, and our partners ship it pre-validated, pre-configured. ExpressPod is a fixed config. We don't modify it. But again, it's there for the lower end of the market. If you'd like more information on these or any of the products we talked about today, you can find information on our On-Command product suite at the top. The communities where you can give us feedback and provide those integration requirements into our products listed right there. And then for anything Microsoft related, the single landing page, Microsoft or netapp.com/Microsoft Solutions. Just come by the NetApp booth and grab a pen. It's written on everything. While you're here this week, if you'd like to get in touch with us, just throw on the hashtag #NetAppMMS. We've got a team monitoring that. It's a quick way to get a question answered or to locate one of our experts if you'd like to have a one-on-one. And with that, thank you very much. I hope you learned something, and let's give away a computer.